on unit errors. We sort of always get the importance of units pounded into our head via various classes and things like that. And I'm going to outline and go over 4 different scenarios where a problem with the units actually caused some pretty severe losses. The first one is Air Canada Flight 143. In the 80s, Air Canada got a new airliner. It was a Boeing 767, and this was one of the first airplanes that was using the metric system instead of the imperial system. So as they were flying this plane, and it had gone out on about a 100-mile trip, and they had stopped at a hangar and were just making normal sort of checkups and things of that nature, and they were trying to figure out how much more fuel they needed to put into the plane to make the trip back. Well, for the density factor of their fuel, they were using 1.77 pounds per liter. The correct unit they should have been using was 0.803 kilograms per liter. This went through about 4 or 5 different people making these calculations, and nobody caught it. So essentially, they needed to refuel with about a little over 20,000 liters of fuel, but they only refueled about 4,000 liters. So an hour into the trip, the plane ran out of gas, and unfortunately, most of the gauges inside of the cockpit were powered by the fuel. They didn't have a backup generator for most of the controls. So they did luck out, and the pilot was an experienced glider. He had been out in several the smaller aircrafts and the gliders and that sort of thing. So he knew a lot of maneuvers that most pilots don't know. And so he was actually able to land this aircraft with very, very limited controls onto what was an old military base. They only had 10 injuries. I think there were 68 people on board. But this is sort of one of those scenarios where it could have been pretty catastrophic with the amount of people that could have been harmed. The next one, I've actually heard about this one in a couple of my other classes. The professors had sort of introduced it, was the Mars Climate Orbiter. This was a situation where the software that was on the flight system was all in metric units. However, the software that the people on the ground were using were in imperial units. And so there's just this mismatch of their calculations and what the units were actually going to be. For the orbiter to make a safe descent onto Mars, it needed to be, I think, it was about 115 kilometers for where it was going to be inserted into the atmosphere. They were trying to be safe, and so they calculated it on the ground that they were going to shoot this with a trajectory so that it would insert the atmosphere at about 226 kilometers. Well, as the days came closer and closer to where the orbiter was actually going to go into Mars's atmosphere, they realized that the altitude that they had figured out was shrinking, and it was at 150, and then the next day it was at about 70. And so they eventually just completely lost contact with the orbiter and discovered, after going back and trying to figure out what had gone wrong with this mission, that the orbiter had gone into the atmosphere at about 57 kilometers off of the surface. So basically the thing was flying in so hot that it just disintegrated. And this was something that they had spent almost $330 million just for naught, because they messed up their units and disintegrated a Mars rover. The next one is Tokyo Disneyland. This one is sort of, they had made this roller coaster in the 90s, and when they were making the roller coaster, they had done everything in English units. And so as they were updating the roller coaster and getting new parts and things of that nature, they were slowly converting it to metric units. So it had come to their attention that they needed to order new axles for the coaster on Space Mountain. Well, they reverted back to their old plans, which were in English units, and so the axles that they ordered were actually about 1 millimeter too small. And so because the axles were so much smaller than they needed to be, as the roller coaster's running, there were just excess vibrations and more stress was being put on these axles than there should have been. So the axles actually just completely broke. The coaster derailed. Luckily, it sort of came to a very slow stop and no one was harmed, because I'm sure they would have ended up with several lawsuits on that. And the final thing I'm going to talk about is the Constellation Project. This was established in 2005 and was to deal with manned spaceflight. They really wanted to do another mission to the moon. And they were using some of the older missions sort of as older projects as sort of a guide to their calculations and sort of the things that they would need for their rockets. Unfortunately, all of these older missions had been done in English units. And so someone came up with the number that for them to take all of these old plans and to convert them to the metric units, it would cost $370 million. And so Obama came out with his last budget, and at first they had gotten $400 million, and so they thought that they would be able to fund it. Well, in 2010 they came out with a new budget, and the funds to this mission had been just drastically cut so badly that they could not continue on with another moon landing because it was just going to cost so much money just to change the units on the planes that it was just, these people were sort of out of a job because of how much it was going to cost to change units. And so some of the conclusions from sort of these different scenarios based on your units. So obviously you always want to include your units in your calculations so that way you don't get anything lost. You're making sure that everything's canceling and right. You're not going from kilograms to liters to pounds or whatever. You always want to make sure you're double checking your units and that they make sense. Check your signs. Dr. Ennis pointed this out. They had messed a sign up on a civil project and the building had fallen down the wrong way because they had a negative instead of a positive. Does your solution make sense? With the first one with the Air Canada flight, they should have thought, okay, we've flown this far, we should have to put in about 20,000 liters. Instead, they only added 4,000. That's a pretty big gap in amount of fuel. You should notice something. So go through your problem, make sure that your answer makes logical sense. And so, like most of these issues were English to metric problems, and it is tricky and it is confusing, but you definitely need to make sure that you're making the right sort of conversions and your factors are all up to date.